So now let's discuss IP layer security. You all have studied IP layer, right? In the same level, we can have ICMP and many other protocols. Although remember that most of the protocols that we club into the layer 3 actually uses IP. Even ICMP uses IP. So actually, ideally, it should be at layer 4, but for some reason, we call all these other protocols as layer 3 protocol. Okay, so in layer 3 protocol, we'll see what are the security flaws. Okay, we will look at ICMP attacks and we'll look at some of the routing attacks. All right, so I have taken contents of this presentation from many places, and please go through it whenever you get time. Networking course. Okay, this IP layer is nothing but inter-networking layer, right? Because it connects different subnets. Okay, it sits over link layer. Okay, and bridges multiple subnets to provide end-to-end internet. Okay, so when internet was designed, they wanted to design a network or create a network that will connect various types of technologies. Right? At that time, there were large number of local area networks like Ethernet. Then there was token ring, token bus, and many other. And they needed a technology to connect all those local area networks. Okay, so it works across different technologies, right? And create end-to-end connectivity. Okay, all right. So what we see is that both physical layer and link layer could be different for each hop, while IP layer remains the same because it interconnects different hops, right? All right. So this we have already seen. So these three layers, physical layer, link layer, and network layer, are implemented at all nodes. Okay. So for example, the laptop there we are connecting will have a stack that will have physical layer, link layer, and network layer. Of course, at the end machine, like your laptop, will also have transport and application layer. How or some routers in between may have just three layers, right? Physical layer, link layer, and network layer. It may not have transport and application layer. Because transport and application layer essentially work end to end. So this diagram we have discussed in the last class as well. Okay, it has various routers. They are interconnected with links. Now these links could be of different type. For example, host is connected to router, maybe over Wi-Fi. Okay, and the router 1 is connected to say router 5, maybe over fiber, and protocol may be Ethernet. Router 5 may be connected to router 3 over some other kind of link, maybe say for example, maybe Sonnet. Okay, and this link could be something else, maybe again, maybe Ethernet or Wi-Fi. Okay, so now these are we can see that a path consists of number of links. The responsibility of network layer or IP layer is essentially to create this path. Okay, say for example, when a packet from node A comes with destination address D, that's the destination IP address D, and when it reaches router 1, the router 1 has to decide based on this destination IP address where to send this packet to. So it has three choices: to router 2, router 5, and router 4. Okay, and it has a table built inside it, which is called routing table, and it consults the routing table and decides on which link to send it to or which output ports to send this packet to. Okay, and let's assume it decides to send this packet to router 5. Okay, in this particular link that's shown here. Okay, when packet comes here, then again this router will look at the destination IP address, which is address of host D, and consults this table, routing table inside, and decides which link to send it to. It has two choices: send it to this link or this particular link. Okay, in this way, the routing happens, right? So packet leaves host A, comes to router 1, comes to router 5, and router 5 decides to send it to router 3, and router 3 decides to send it to host D. So there are multiple protocols that we use, right? So these are called routing protocols. Okay, routing protocol, different types of routing protocols are, for example, OSPF, BGP, ISIS, etc. Okay, and these are actually kind of distributed protocols wherein each router sends information to its neighbor, and this neighbor exchange information further, and so on, and then all these routers will have same information about the network. Okay, let's move on. This diagram here shows how we can create end-to-end path based on local based on different links, right? So here between router A and host A, we have a link layer protocol that works, that transfers the packet from host A to router 1. Between router 1 and router 5, there is another link layer protocol that works over different physical layer, and then packet comes here, because once link layer transfers a packet here, the router here will look at the IP destination address. Okay. Based on that, it will take decision which link to send it to, and then it decide to send it to this particular link, and then looks at the characteristics of this particular link. Say if it's, say for example, Ethernet, then encapsulate IP packet inside Ethernet and send it to this router. This router, when receives this packet, removes, and this is the end-to-end path. Note that network layer or network IP protocol doesn't really bother about what kind of contents are sitting inside it, right? So it's not bothered about TCP or UDP traffic or HTTP traffic, etc. Right? It does not really look at the contents while doing the routing. Simple? Okay. Sure that you would have done distance vector routing and link state routing. So these are the two routing techniques, right? Anyway, so we'll not go into detail, but we'll look at how attacks can happen. Let's look at the IP packet structure. I'm sure this is revision for you. Okay, the most important field here is, of course, IP address, which is 32 bits. This field here specifies the length of entire IP packet. Okay, then there's a type field here, which is actually called protocol field, which says that what is the content inside, right? Because the payload will contain information about something, right? Say, for example, it's running TCP. Then whatever bits are here inside will be interpreted differently than if it is UDP. Okay, so so this field is actually determines what kind of protocol is running inside it. Right? Okay, next is, for example, value 6 is for TCP and 17 is for UDP. Of course, then we have 32-bit source and destination address. Okay. We'll learn later, I mean, if we get time, that how 32 bits are enough, right? Because, see, 32 bits allow only 2 raised power 32 addresses. And number of, okay, so again, these points we have discussed several times, but it's very, very important. So we will relook at it. When internet was designed, it was designed as an academic activity, right? Okay, so designed in Stanford and also in MIT and other universities, then collaborated with government funding. So nobody thought that internet will become de facto standard for communication, and at, say, after 30, 40 years when it was designed, nobody envisioned that world's almost whole data will go over internet. Okay, however, it has become de facto standard, or it has become the technology, communication technology. Okay, so it was designed at that time because it was designed in academia. And the speed's very, very, very low, right? I mean, if you can do few kilobits per second kind of transfer, then it was considered to be high speed at that point in time. So whole idea was to somehow interconnect various different types of networks available at that point in time and create end-to-end communication. Because if there is a, say, Ethernet, then some places they are using token rings, some places they were using some other network, and these networks were serving locally, but there was no network which will interconnect them, right? So internet came in at right time to interconnect those small islands of networking technologies. Then second thing is that the equipments were not very reliable, right? And the links were not reliable. So most of the error rates were higher. So they wanted to create a network which is failure resistant. Then they wanted to create a network which will serve to provide different kind of services. Okay, all right, and it will be easy to manage. It should be cost effective, and there has to be accountability of resources. But so we have studied all these priorities in the past, right? But nowhere it was mentioned that it has to be secure. So it was not designed security in mind. And we know the reasons for that. It's designed primarily for connectivity. It was designed with implicit trust that there's no bad guy. And then they finally thought that if security is to be provided, it will be done end-to-end using encryption or some other method. Basic internet protocol or structure does not provide anything for security, but we have created some things around each layer to provide security. For example, at IP layer, we have IPsec, right? We'll study that later. And then higher layer, we have TCP level security, right? And then we have firewalls, and then at layer 2, we have each switch will have some mechanism or other to make sure that attacks are not there. All right. So let's look at layer 3 protocol security flaws and different kind of attacks. So do you have any question now? Okay, so we will study only few vulnerabilities or attacks in layer 3. Okay, and possibly in the next class we'll look at the remaining ones, or we move into TCP attacks. Okay, now, so what we have seen here, I will go back to diagram. Okay. Okay. This is a path. Okay. And there is a router here. It means that whatever A is sending is available to router 1. Can this router be malicious? It can be, because nobody is controlling all this, right? I mean, these happens based on trust, right? I mean, it could be, this router can be in China. Okay, and how do you know that this router is trustworthy router? Okay, it could be anywhere else, right? I mean, not necessarily China, but it could be with somebody and who is interested in seeing what somebody is sending, say what A is sending. Okay, okay, all right. So, so network packets or IP packets will pass to untrusted hosts. Okay, and that untrusted host can do anything. It can do eavesdropping or sniffing and read the content of the packet and so on. Second important hole is IP addresses are public. That's when internet was designed, nobody thought, right, that we have to make it private. So, for example, if you have you seen the telephone directories? Okay, the BSNL, earlier there was only government that provided telephones in the country, and it published directory. So I remember having seen directory for daily. It used to be almost like 5,000 pages long, but it had name and phone number of every person that has telephone. Now that's interesting, right? Because the whole world didn't believe that, once this information is available, anybody can do mischief. So it's like, when you have mobile phone, you are going to share mobile phone number only to few of your friends, right? But let's assume that your everyone's mobile phone number is made public. Obviously, you may not want to do to make your phone public, because now there a lot of people can exploit that, because mobile phone number is an important security parameter everywhere, right? Okay, even two-level security, for example, even with Google, it may ask for your mobile number, or when you're doing banking transaction, it will ask your mobile number and send OTP over that. Okay, so having IP address public is not good thing. So attackers can always exploit that. Okay, then again there is a very basic mechanism. You can create IP packet, and anybody can create IP packet. Okay, let's assume that 2D wants to create a mischief. He can always make a packet with the wrong source address, source IP address. Okay, he can pretend to be Alice or Bob for that matter, right? Or it can send a packet to some very important person with garbage inside. 2D may want to send a packet to, say, Mr. Trump, right? Because Mr. Trump's IP address possibly is known, and then he can put a garbage inside and send it to Mr. Trump, right? So what will happen? Mr. Trump's machine will receive the IP packet and spend some time looking at it, who has sent this packet, right? Because machines do trust everything that comes in, and until machines look at what is inside, who has sent it, they have no way to know that packet has come from trusted source or from a malicious user, right? Or from attacker. All right. So routing protocols are designed assuming trusted parties, and this all can be exploited now. Okay, and then what are the IP level vulnerabilities? So once IP addresses that sender can decide, right? Sender ideally should send its own IP address, but can change source IP address. Similarly, can play with destination IP address. So we can have this kind of attack called spoofing attacks. Okay. Second kind of attack is wherein your packet is admitted to network, or your packet is authenticated based on the IP address it carries, right? Okay. For example, if you want to beat a security protocol, okay, and you want to enter, for example, a police station, okay, simply put on a dress of policeman. Right? Nobody will stop in the first instance, right? You will get inside, and then your job is done, right? Your intent is to go inside a police station, of course, where entry is restricted. You just get into a police station by just putting up dress of a policeman. Okay, simple as that, right? So similarly, IP packet with right IP address or some IP address which are allowed to go inside can enter the facility, right? So there are protocols like remote login, RSH, rhost, etc., and they allow packets to have access based on the IP source address. Now, an attacker can now find out the IP address of a trusted source and who is allowed to have access to resources, and can then pretend to be that source, trusted source, right? So it means it can change its own IP address to trusted source IP address and then send the packet. Okay. So there is also there's a feature called fragmentation. if the IP packet size is very long, okay, and there are some switches and routers in between which can't handle a long IP packet, then they can request fragmentation of that smaller size, right? So what will happen is that then they can drop the packet or and then send the message back to the source through ICMP packet to retransmit this with smaller size packets. Alternatively, they can fragment the packet and send it upwards, right? Okay. And then another feature of IP that can be exploited is the broadcast capability. Okay. So now let's look at the first attack, which is IP address attack or IP address spoofing. Now it's very simple, like as we have seen in case of MAC address spoofing. Here the attacker can use the forged IP address. Okay. What is he going to get out of it? If he forges the source address, wrong source address, or somebody else's source address, then you can cause trouble, right? I mean, for example, machine C sends packet to machine A. Okay, however, it uses a source address of B. When the machine A responds back, then it will respond back to B. And B will not know why he has got the message from A, right? So some kind of mischiefs can be done by that. Okay. And of course, we have studied the second point that IP address, the forged IP address can be used for authentication or getting entry into prohibited area. So how do we then control IP spoofing, wherein we are using either wrong source address or wrong destination address? Okay. We can do some kind of filtering, right? So for example, a packet is coming from outside. So there is a subnet and packet is coming from outside. And that has IP source address that is from inside the network. Okay. It means that what a firewall can do is that look at the source address of incoming packet and find out the source address is source address of a machine that's inside. Essentially, it means that there is some kind of fraud. Similarly, egress filtering can be done. It means that if somebody from inside the net is sending a packet to outside with a IP address that does not belong to that subnet, then obviously one can find out there's something wrong happening. And then there are some higher layer protocols to find out this kind of spoofing. For example, TCP uses sequence numbers. Note that TCP data will sit inside IP packet, right? And then TCP uses some sequence numbering, right? So anybody who is trying to spoof a TCP packet will have to use a sequence number, right? And the guessing sequence number will be difficult. Right? So in this way, higher level protocols can take care of can do something to avoid IP address spoofing. All right. So this is about IP address spoofing. Any question?
Yes, sir.
Okay. All right. Okay. Let's now move over to ICMP attacks. Okay. I'm sure you have studied ICMP in your course. ICMP stands for Internet Control Message Protocol, right? Essentially, these are the error messages that come from anywhere in between the route, between source and destination. Let's assume there are machines and machine is not able to process the packet it has received for some reason. Then it will send the information back to source machine that something has gone wrong. Okay, so these messages report error and other conditions from the network to end hosts. And then end machines take actions to respond to error. For example, somebody is sending IP packets at very fast rate and there's a congestion in the network. Then router in between may send the information back to source that there is a congestion and may such that the source node will reduce the rate of transmission. Okay. All right. So, but these messages are not authenticated. Okay. So anybody in between can send these messages. So what is the impact of that? Because again, when the protocol was designed, it was nobody thought that ICMP messages can be fraudulently used. I mean, it can be used to disrupt the network, right? Nobody thought that there is a 2D inside who can create fraudulent ICMP message to disrupt the network. All right, so the problems are as follows then, right? Entity can easily forge variety of ICMP error messages. Okay, for example, there is one message called redirect. So if there is some problem in the network, then a node can inform the end host that it should be using different first hop route. Okay, the route to the first hop, it could be different, right? So instead of going one outgoing link, use some other outgoing link because there's some problem in the network. Secondly, fragmentation. I mean, as we discussed earlier, that if the packet size is larger and between node is not able to process it, maybe there is a problem at layer 2 switch. It is not able to handle large size packet, then packet has to be fragmented, right? Now, there is another message which says the destination unreachable, right? You would have seen this message very often, right, when you use protocols in normal use, right? So what does it mean, right? I mean, if some switch in between can create this message and send it to a number of sources, the destination is not reachable, then they will stop communication in some sense, right? And there are a large number of ways these ICMP messages can be exploited. Okay, there is one paper which is given here, is sense.org, which talks about this kind of threats. So please go through it. I mean, of course, you'll have to do your login and create your password there to pull out the paper. Okay, so the attacks that we'll study in brief are essentially three. Of course, there are many more, and we will not look at them. There are three attacks that we'll study: are ICMP redirect attack, ICMP smurf attack, and third is ICMP ping of death attack. Okay. First one is ICMP redirect attack, or based on ICMP redirect message. This message tells a host to use a different gateway on the same network. Okay. So what happens that the diagram shows a normal path through a good gateway. Okay. Now attacker can spoof an ICMP redirect message from good gateway to redirect traffic to attacker. Okay, so what we'll do is that spoof the IP address of this gateway, create ICMP message such that host A will think that has come from good gateway, and it will say that send the message through him, or this it says that use some other method, right, or different gateway. So as a result of that, now message will pass through this attacker. Okay. Okay, all right. So this is one simple attack that by simply sending ICMP redirect message, the whole traffic can be diverted through the attacker. Now, second attack is IPMP smurf attack. Right? This is based on a spoofing of IP address. Okay. This is also DOS attack, denial of service attack. Here is an attacker on the left hand side and the victim on right hand side. This is gateway, and gateway has number of machines connected. Okay. attacker will send an ICMP echo request. Okay, the ping is kind of hello. It comes under echo request, right? That we ping a machine, it responds back, right? So ICMP echo request will have source as victim's address, source address. So the ICMP will have victim's source IP address and victim's IP address as source address, and then destination address is the broadcast address. Okay, so it will create an ICMP packet. Attacker will create an ICMP packet with source IP address is victim's address and destination address is broadcast address, right? So this message, ICMP message, which is echo message, right, this kind of ping message will go to all these machines. This here. And once they get the echo message, they will respond back, but they will respond back to victim's IP address because that is shown as a source address, right? So they will send the message back to victim. Okay, and then this victim machine has to handle them, right? And they once the machine is busy handling them, it cannot do anything else, right? Okay. Now we have shown on here only 3 machines. It could be thousands. Okay. So we have studied now the next attack, the same attack, which is amplified version of the earlier one, using botnet. So attacker is connected to different masters, and masters are connected to daemons, and these daemons can use ACMP machine, ACMP message, and then they can attack a victim, right? They can spoof this guy's address, victim's address, as source address. Okay, and then attack can happen over victim, right? All right. So this can be done in number of ways, right? Demos can directly send IP packet, right? But they will be caught. So instead of that, they can use echo message and send it to different machines, and they will respond back at victim's address. All right. Let's look at the third ICMP attack, which is called ICMP ping of death attack, or it is a distributed DOS attack, right? Distributed denial of service attack. Okay, this is again very simple attack, right? I mean, attacker sends a ping request of packet larger than 64K, that's 536 bytes. Okay. So what will happen? This large ping packet will be fragmented into small packets in between. Because this size is larger than a node can handle in between, right? And these fragments will finally go to end machine. Okay. The destination machine, which is the victim now, will reassemble these ping packets, right? Okay, and of course, in order to reassemble it, will put them in a buffer, these pieces into buffer, and which buffer will be overloaded and will cause the crash. Okay, this is a very, very interesting attack, right? It happened recently. Okay. All right, so these are the 3 attacks based on ICMP. Okay. Okay, now we'll study routing attacks, right? All right. Now, I will request you to read something about link state routing and distance vector routing, right? So, of your own, because those 2 protocols are very interesting protocol. However, today we will not discuss these, right? Because it will take each protocol will take at least 1 hour for good explanation. Okay, I am sure you would have studied source routing in IP, right? I mean, wherein source can tell what route to take. Okay, so packet can be forced over route. It's kind of tunnel. Normally in IP routing, we have seen that once packet leaves the source, it depends on network to decide where packet will be sent to, right? Now it's a very powerful method, right? Because if the network decide where to send, the network can take care of situation in the network. For example, if some links are not working or is some other disruption, okay, then packet can go over different path, and these decisions can be taken by routers in between based on exchange of information between them. Okay. However, there is a method by which packet can be forced over a path. Now, this method is essentially used to collect statistics or doing some kind of diagnostics. Okay, these are very rarely used and primarily for troubleshooting. Okay. However, attacker can use source routing to probe the network by forcing packet to a specific part of the network. So it means that if an attacker defines a source route that passes through some routers or some part of the network which he wants to get access to somehow or wants to collect some information, then he is able to do so. Okay. So, for example, using source routing, an attacker can collect information about network topology or other information that would be useful for performing an attack. Okay. Or, for example, attacker can use source route to direct packets to bypass existing security restrictions. Okay, for example, for any restricted network, entry and exits are well defined. Okay, so however, there might be sometimes some connections which are not very well known, but known only to few people, that can be used for entry into network. For example, in your campus, for example, there is a main gate, okay, through which most of the traffic comes, and that's the known to everyone, right? But nobody will know there are 4 or 5 other gates also, or small pathways, right, where which you can go out of campus. Similarly, in a network, there can be some way of bypassing the main security. How would this bypassing will happen? If there is a normal routing based on the routers in the network, then this security cannot be bypassed because this router will force messages to go through a particular route which passes through security gateway or some kind of firewall. But through source routing, you can avoid that firewall, maybe get into the network somehow. So, the attackers have used source routing, but the only way to avoid this is they disable source routing in all routers. Okay, so nobody can force anybody to use source routing. All right. Okay, so this was in general about source routing protocol, but we know that there are various kinds of other protocols. The routing happens using protocols like OSPF and ISIS, which is based on link state algorithm. Essentially based on Dijkstra's algorithm based on shortest path. And there are other protocols like RIP, IGRP, and EIGRP, which are based on distance vector protocol. Okay, so these two protocols are largely used in finding on paths. And there is one very important protocol that is called BGP, or Border Gateway Protocol. Okay, so this protocol is called Exterior Gateway Protocol. Exterior to gateway protocol, and designed for exchange, routing, and reachability information among autonomous system on the internet. So your campus may be treated as an autonomous system. Okay. So outside of that, in order to interconnect that different autonomous system, we use BGP. Okay. Now BGP itself, the draft is more than a few hundred pages. It's quite complex. I tried, but so what are the security issues in routing protocol? Again, look at the routing protocol. These routing protocols exchange information with each other. Okay, and these are fully distributed. Okay, for example, a node may exchange information about its neighbors. Okay, and then these neighbors are going to exchange information about some other neighbors, and then information will reach to the whole topology, and they will decide at each step that some calculation will happen, right? So in this way, a node can find out path to any other node, and so on, right? So it's totally based on trust. Okay, it means that the distributed algorithm works when everyone is honest. Okay, but there can be malicious host that may advertise wrong routes in the network. There may be bogus routers. Okay, and so on and so forth. All right, so let's look at this example. This defines a routing protocol between some nodes, is nodes A, X, Z, Y, and B. Okay, these are the nodes, very small networks shown here. Okay, now A will send routing info to X. Okay, so for example, now X will know that A is connected to it with the cost of 1, assuming that this cost is 1. Okay, now in the next step, Z will know that A is X, cost to X is 1, and then from this it will find out cost to A is 2. Okay, similarly Y will find out cost to X is 1, and then the cost of A is of course 2. Okay, in the next step, basically this will try to find out whether it has cost lower than 2 or higher than 2. Through this step, it will find out that cost from Y to A is 3, which is larger than the cost Y has through X. Okay, so cost remains the same. And in final step, B will find out the cost from A is 1, 2 plus 1, 3. Okay, all right. So in this way, B will find out the cost to A is 3, and Z will find out the cost to A is 2, Y will find out cost to A is 2, and X will find out cost from A is 1. In this way, each node can find out the cost to every other node in the network. What we have shown is step for all other nodes knowing the cost for A, cost from A, right? As cost is nothing but distance here, we can assume. Assuming that each link has a cost of 1. Simple. Now, where can anybody do fraud? All right. So this shows path between A and B, right? All right. Now we can do attack on routing table. Now let's assume node Z says my cost to A is 1. Okay, instead of 2, it just lies, right? And now based on this advertisement, all other nodes will change the cost. Okay, so for example, Y may decide that my route to A is through Z instead of X. So the cost is between Y and A would again be 2, right? Because this cost is 1, and Z is selling that cost to A is 1, so 1 plus 1, 2. Okay, and similarly, B may think that cost to A is 3, which actually is 3, but we take this one, right? B to Y to Z to A. Okay, so now the routes are changed, and what we have shown here is a very trivial example, but it could be different. Okay, for example, there are multiple nodes here in between, right? Then Z can advertise it wrongly, and then message can pass through this route instead of all nodes sending it through this simple route. Will send it through this route. Okay. All right. So in this way, if a node tells a lie, right, then the whole routing will change, right? And in this way, a node can force traffic to pass through it, and may have some intentions of doing that. Okay. All right. Okay. So what is the countermeasure of that? Countermeasure is have some policies which will say that we'll accept routes only from certain nodes, network entities, right? And we can also use routing registries and certificates. All right. Okay. All right. So that's the end of layer 2 security. Right. So to summarize, IP layer is the most important layer of the internet. Now we say it important because if IP layer is not there, then internet will not exist. It defines IP packet. It defines a routing. Okay. Okay. And this IP layer is based on the principle that everyone is honest, right? But so that creates a lot of hole in the whole system, which can be exploited by attackers. And we have as simple as that, that IP address can be spoofed. Right? It's same as, right? I mean, if you send 1,000 envelopes or 1,000 courier to somebody or 1 million couriers to somebody, right? Suppose I receive 1 million courier from somebody and the courier guy will dump into my house. So what will happen? I will have to throw this out, right? Or do something about it, and then it will waste my time. Second thing is I can somebody who's sending me millions of couriers will hijack the whole courier service, right? Nobody else will be able to send it. Now in real life that's not possible because there's a cost associated, right? But internet you can create millions of packets or billions of packets without any cost, right? So on internet such attacks are easily possible, and you can send it to anybody. We can put your, you can pretend it to be anybody else when you're sending the billions of packet to somebody, right? And there is no check because no authentication on source or destination address. Okay, all right. So we have studied IP address spoofing. We have also seen how ICMP protocol can be exploited to have different kind of attacks, right, which are basically redirect attacks, Smurf attack. The spelling is wrong here. Smurf attack or ping of death attack. And then we have seen very simple routing attack, which is source routing attack and a routing protocol attack. I mean, the way routing protocol exchanges message and then a router in between or switch in between can lie about its own state. Right? So based on that, attacks can happen. All right. So these two very simple attacks in routing protocols or routing layer protocols we have seen. Okay. All right. Any question, folks? No? All right. Thank you very much. See you in the next class then. Bye.